Example number 1. Use rectangle to estimate the area under the parabola y equal to x squared from 0 to 1. So let's draw the parabola. So if I have this point is 1, then the parabola will pass through the point 1, 1. I will have two ways to do. I will use the right endpoint and the left endpoint. Okay, so first of all, I'm going to use the right endpoint and then the left endpoint. And I write it 4 because I want to divide 1 into 4 equally sub-interval. So this is going to give me 1/4, 2/4, which is 1/2, 3/4. Okay, so first of all, how do we use the right endpoint to make the rectangle? So we use the point 1, 1, and then we draw the rectangle. Okay, we're going to use the second point from the right side, which is this one, and make the rectangle. We use the third point from the right side, which is right here, and then the fourth point. So the area will be the area of the rectangle. So each rectangle, the formula is length times the width to find the area from the smallest one, which is the yellow. You notice that the width is 1/4 and the height is this much. So let's look at this point right here. If you plug 1/4 into the function, you're gonna get 1/4 square, right? So the height will be 1/4 square. Plus, for the next rectangle, which is the pink color, so the area will be the width, which is 1/4 again. But right here, at this point, the point on the x is 2/4, which is 1/2. When you plug into the y, you're gonna get 1/2 square. So this is 1/2, and then you have 1/2 square for the y part. So we will do 1/2 square. So similarly, the width is 1/4 all the time, and the next point is 3/4. When we plug in, we get 3/4 square. And then 1/4. The last point will be 1 square. Because we plug in 1 for the x part, we get y part is 1 square. Simplify this, we will get 15/32. And the answer is using the calculator. So we get like this. Now I use the left endpoint in the second method. So first of all, you draw this line, but you are going not to use that line. You're going to use the point on the left side of that. So which is 3/4, and then make the rectangle. And then you use this point, make the rectangle. And you use this point to make the rectangle. And the last point, you're going to use 0, and then the rectangle will be like a line. So for the left rectangles, the sum of the left rectangle, we will get, for the first one, the width is 1/4, but the height is 0. The next one, the width is 1/4, which is this rectangle. The height is 1/2 square. And then similarly, So for the last one, we have this rectangle. So this point for the y part will be 3/4 square, which is the height of that rectangle. Simplify this, we get 7/32, 0.21875. So you can see that from the right endpoint, we have those extra pieces like this. The purple is the extra pieces. So from the right endpoint method, we have overestimate the curve, the area under the curve. The area under the curve is just this part, right? Yeah. Okay. So we have the one on the top is the extra pieces. And then the area under the curve for the left endpoint we have is underestimate. So we can say that the area, I use A for the area of under the curve parabola y equal to x squared, is between these two numbers, 0.21875 and 0.46875. What if we divide the curve into A equally intervals, A rectangles, and we use the left hand side and the right hand side, the right endpoint and the left hand point, same method, and it will give us the answer. The area will be between 0.2734375 and 0.3984375. So continue to doing that. If we have the 50 rectangles, then we will have the answer is 0.3234 and 0.3434000. If we are doing like 1000, then the area will be between 0.3338335 and 0.3328335. Okay, of course we cannot do the 1000 or the 50, but we got the answer, and those answers are from the book. And what can we say from this is that when we have the more rectangles, okay, so you can see that the area is stay in the between of these two numbers, so we can have the feeling that the area is like 0.33333, and that is like 1/3. So it's like an idea of limit, right? And in example number 2, we will prove that the limit of the sum of the rectangle for n go to infinity. That means you will have a lot of rectangles. The sum will approach to 1/3.